This is a piece of metal. This is a piece of wood. This is piece of metal. Two are I'm taking. I'm taking two pieces. These two pieces are placed. Two pieces are placing inside the fridge. Inside a fridge. Inside a fridge. Inside the fridge. After 15 minutes, 15 minutes, and wood is taken out of the fridge. Metal is taken out of the fridge. Out of the fridge. This is a wood. This is a metal. Metal. We are taking two pieces are two pieces are taken them out of the fridge. Out of the fridge. This is your friend. This is your friend. Your friend is touching the wood. Uh, your friend is feeling very cold. Now your friend is touching the metal piece also. Your friend is feeling very cold. Very cold. Both are cold. Both are in the cold side. But here, so metal piece is more cool than to the wood piece. Metal piece. Metal plate is very cool than to the wood paste. Wood paste. This is a very cool, cold, very cool. This is a C means cool, cool, cool. This is a metal. This is a cool. This is a wood. This is a wood. Very cool, very cool. So metal piece is very cool than to the wood piece. Wood piece. What is the difference between the cool? What is the difference between the cool? You see, in this situation, this person is touching the metal piece. This person feel cold. Will feel cold. This is a wood piece. This is a metal piece. Two pieces are placing inside the fridge. Inside the fridge. What will happen? So these two pieces are they are cool. They are cool. These two pieces are last heat. These two pieces. This is a wood. This is a metal pieces. We have the two pieces. Two pieces are keeping inside the fridge. After 15 minutes, 15 minutes, they are uh, wood piece and metal piece are taking out from the fridge. Out from the fridge. Wood and metal piece they are very cold. They are very cold. They lost heat energy. They lost they lost heat energy. They gain cool. They gain cool. These two pieces are lost heat. The two pieces are gain cool. Gain cool. Now your friend is touching the wood means this person is feeling cold. This person is touching the metal piece. This person is feeling very cold. Very cool. This person. This is a person is not touching to the wood piece. He is not getting any cold. This person is touching to the metal piece is getting very cold. Suppose this person is not touching to the this metal, he does not get any cold. Now in this time, this person is touching metal is metal is very cool into the wood piece. That means this is a person, this person, what will happen? Heat flows from. This is a body. This is a body. This is object. This is a object. So this is a body is taken as body at a high temperature. High temperature. This body is at a low temperature. Low temperature. Heat flows from heat. Heat energy flows from heat energy flows from heat flows from high temperature but body at heat flows from body at high temperature to body at low temperature. Heat flows from like this. Heat flows from like this time. So this is the heat energy flows from our body to metal piece. The time is getting very cold, very cold. This person lost the heat. This person gained the heat, gained the heat energy. In this situation, heat flows from this is a body, this is a body, this is a object, this is a object, object. This is a body and object. So this is at a low temperature. At a low temperature. This is at high temperature. High temperature. High temperature. High temperature. Now heat flows from high temperature to low temperature. This is a body getting hot. This body heat energy flows from object to the your body, object to the your body. You're feeling hotness. You're feeling hotness. This time you're feeling this person is feeling hotness. Hotness. This person is feeling coldness. Coldness. Okay. This person feels coolness. This is a hotness. Hotness. This is a you're feeling. This is a activity one. Activity one. This is a activity one. Activity one. So this is a body at high temperature. Body at high temperature. This is a body at low temperature. Body at this body indicates high temperature. This body at low temperature. Heat flows from heat flows from high temperature body to high temperature, body to low temperature. This is a heat flowing. Heat flowing. This is a activity one discussion. Activity one discussion. What I'm explaining? Okay. This is activity one. Uh, Next, thermal equilibrium. Thermal equilibrium. So thermal thermal equilibrium and heat and temperature. Heat and temperature. Thermal equilibrium means so this is both bodies A and B. This is A and B. So this is two bodies. This body having 50 degrees Celsius. This body having 50 degrees Celsius. These two bodies are in thermal equilibrium. Thermal equilibrium. Thermal equilibrium means this is A body. A body having temperature is 50 degrees Celsius. This is a B body. B body having 50 degrees Celsius. Both bodies having same temperature attained. Both bodies having achieved same temperature. These two bodies are in thermal equilibrium. Thermal equilibrium. Now heat is in this condition. Heat does not flowing from A to B, B to A. Heat does not flowing in this situation. Next, this is A body. This is a B body. B body. This body temperature 70 degrees Celsius. This body temperature is 30 degrees Celsius. These two bodies are contact each other. This is A body. This is a B body. This is a high temperature. This is a low temperature. High temperature. This is a low temperature. Heat flows from high temperature to low temperature. Up to the heat is flowing from high temperature body to at low temperature body up to both bodies is attain same temperature. After heat does not flow from one body to other body. That is the thermal equilibrium. Heat means heat is flow from body at high temperature to body to low temperature. Low temperature. Temperature means temperature is degree of hotness, degree of coolness is called as temperature. That is the temperature. Now, so that is that is the thermal equilibrium. Thermal equilibrium means this is the two bodies, A body, B body. A body having temperature 50 degrees, B body having 50 degrees Celsius. Two bodies having same temperature is called as two bodies are in thermal equilibrium. This is A body, this is a B body. A body having high temperature, B body having low temperature. Both are contact each other. Heat flows from body at high temperature to body to low temperature. Up to both heat is flowing from still up to both bodies are having the same temperature. The situation A and B are in the thermal equilibrium. Heat and temperature. Heat means heat flows from high body at high temperature to low temperature. Temperature indicates the degree of hotness, degree of coolness. That is called as the temperature. That is the called as temperature. Now, that is the temperature. So next, for example, practical. Suppose, for example, my body is, I'm not feeling either hotness, coolness in surrounding atmosphere. Surrounding atmosphere. My body is not feeling either hotness, either coolness in a surrounding atmosphere. Surrounding atmosphere. That means my body and surrounding atmosphere, both bodies is having same temperature. Same temperature. My body is thermal equilibrium in a surrounding with a surrounding atmosphere. Surrounding atmosphere. Okay. Next, furniture in a room with air. Furniture and air having both are same temperature. Same temperature. Furniture in the room is thermal equilibrium. Air in the room. Air in the room. That is the example. That is examples. Okay. Okay. Next activity. Activity two. Activity two. In activity two, what we are going to explain in the activity. So we are taking the glass tumbler. This is one glass tumbler. This is another glass tumbler. This is a both are transparent. This is filled with hot water. Hot water. This is filled with hot water. Hot water. This is filled with second test tube is filled with cool water. Cool water. Cold water or cold water. Cool water. Okay, cool water. So I'm checking that this is a laboratory thermometer. Thermometer. This is a bulb of this is a mercury. Mercury. This is a thermometer. So what is the use of thermometer? Thermometer is used to find temperature. Find the temperature. Now this thermometer is thermometer. Reading of thermometer. Reading of thermometer. Reading of thermometer kept reading of thermometer lies inside the hot water. This is a laboratory thermometer. Laboratory thermometer lies inside the cool water. Cool water. Now in this can, so first we have to note down this mercury level. So we note down level of mercury level. Level of mercury level. So after this is a reading of thermometer kept inside the hot water rises. Level of mercury level increases from initial values. This is mercury level. So this is a reading of thermometer kept in cool water. So level of mercury levels slow slow down from initial value. Initial value. Now in this time, so what happened in this situation? This is a hot water. Hot water taken at high temperature. At a high temperature. High temperature. Next, mercury. Mercury is taken as low temperature. At a low temperature. Low temperature. This is a high temperature. This is a low temperature. Hot water. Hot water is at high temperature. Mercury is at a low temperature. Heat flows from hot water to heat. This is heat flows from hot water to mercury. Hot water to mercury. So next, in this situation, heat flows from this is a cool water and mercury. Mercury. Okay, in this situation, mm, this is at low temperature. Low temperature. This is at high temperature. High temperature. Heat flows from high temperature to low temperature. High temperature to low temperature. In this situation, heat flows from hot to here. Heat flows from body at high temperature, body to low temperature. Heat flowing like this. Heat flowing like this. Heat flowing. In this situation, heat flowing like this. Okay. So heat flowing from high temperature to low temperature. Temperature. Low temperature. In this situation. Now, in the third case, suppose for example, this is a mercury level. Mercury level. Suppose for example here hot water or cool water. Cold water. Whatever water. Hot water and cool water. This is a mercury level. Mercury level. So both bodies is having same temperature. This having same temperature. Same temperature. Both bodies are having the same temperature. Same temperature. Same temperature. Both bodies are same temperature. Both bodies are same temperature means no heat flows. Heat is not flowing. No heat flowing from one body to another body. This is suppose what is a mercury level state? Study, study state. Mercury is mercury. Mercury is study state position. Study state position because this is a thermal equilibrium. Thermal equilibrium. Thermal equilibrium. In this situation, we call thermal equilibrium. Thermal equilibrium. Here, so in this, there is a here temperature difference. Temperature, temperature difference. Temperature difference. Here, there is no temperature difference. There is no temperature difference. Temperature difference. So in this case, in this case, temperature is there is a temperature difference. Temperature difference there. This is a hot body. This is a hot body. This is a cool body. Hot body, cool body. High temperature, low temperature. Heat flowing from body to high temperature to low temperature. Now in this situation, this is a cool body. Cool body. Mercury is hot body. This is a hot. This is a cool. Temperature difference there. Heat flows from body at high temperature to low temperature. Heat flow. Here, heat flow. In this situation, hot body or cool body and mercury both are having same temperature. Same temperature means level of mercury is steady state. Because this is both bodies are having the same temperature means both bodies are in equilibrium. Thermal equilibrium. There is no temperature difference. This body having same temperature. This body having same temperature. Both bodies is having same temperature. Both bodies are having same temperature. Same temperature. Both bodies are having same temperature. For example, 70 degrees Celsius, 70 degrees Celsius. We call both bodies is having same temperature means both bodies is having same temperature means both bodies are in a thermal equilibrium. Now mercury level is steady state. There is no temperature difference. In this situation, there is temperature difference. There is temperature difference. Heat flows from hot body to cool body, and heat flows from hot body to cool body. There is a temperature difference. Level of mercury. Mercury in this time, mercury level is increased. In this time, mercury level is decreased in this time. So here, mercury level is increased. Here, mercury level is decreased. Your mercury level is steady steady state. This is we have the situation. First situation, second situation, third situation. We have the three situations. Three situations we have. Same sir. Same sir. Who's the device? Okay. This is so next in this concept we have uh, multiple subparticles. This is this is A body, A body. This is a B body. So we have the two bodies. These two bodies are thermal equilibrium. That means A body and B body having same temperature. Both are in thermal equilibrium. A body and B body having same temperature. A body is the thermal equilibrium with the B body. Now these two bodies are contact with the C body. A body and C body having same temperature. A is in thermal equilibrium with the C. B body and C body having the same temperature. Both bodies having the same temperature. B body is thermal equilibrium with the C. Total A and B, C are having the same temperature all are in the A, B, C or normal equilibrium situation. We call this is a zero earth law. We call this is a zero earth law. We are calling. We are calling zero earth law. Okay. So next. So here in this situation, activity 3. So temperature measure on the Kelvin scale. Kelvin scale. We call absolute temperature. Absolute temperature. Temperature is measured on Kelvin scale is called as absolute temperature. Temperature, temperature, temperature is measured on Kelvin scale is called as absolute temperature. Absolute temperature. Now, next activity I'm going to explain. Activity 3. Activity 3. In this activity, so what we are going to explain in this activity, two balls. Two balls. This is a one ball. This is one ball. This is a second ball. Second ball. One ball is one ball filled with the hot water. This is a hot water. Hot water. Second bowl is filled with second bowl is filled with cold water. Cold water. Cold water. So cold water. Next, I'm checking. This is food grains. I'm checking food colors. Food colors. Food colors. I'm checking food colors. I'm taking food colors. This is a food colors. This food color. I'm checking two bowls. One bowl filled with hot water. One bowl filled with cold water. Next, I'm checking food color. This food color keeps on. This food color keeps on. This food color keeps on surface of the water. Surface of the hot water. And this food color keeps on food color keeps on top surface of the cool water. Cool water. Now, just so we have to observe the motion of the food colors on the surface of the earth water, and now we have to observe motion of the food colors on the top surface of the cool water. Cool water. Now, this is a food color of food color. Food color. Food color is moving random directionally. Random direction. Now here also food colors moving random direction. Random direction. At the same time, so this is we have to observe motion of the food colors. Food colors are random directionally. Random directionally. Random directions. So here we have to observe what we are going to observe. This is what we call this is food colors. Food colors on the hot water. This is a food colors on the cold water. Cold water. Cold water. We have to observe motion of the food colors on the hot surface. At the same time, we have to observe motion of the food colors on the cold water. And so these food colors are moving random directionally, random directionally, and the molecules of the water are also moving random directionally. Random directionally. Now the body, any body possesses kinetic energy. So this is a particles. This is a food particles are moving random directionally. Motion of sorry, molecules of the water also molecules of the water also moving random directionally. Random directionally. So any particles are in the motion. Any particles are in the motion, and the body possesses kinetic energy. Kinetic energy, and these particles are moving random directionally, and the motion of molecules of the water is moving random directionally. Random directionally. So particles are in the motion. The particles of the body having kinetic energy. Kinetic energy. These particles are moving random directions means the particles having the kinetic energy. Kinetic energy. So kinetic energy. Now, average kinetic energy of the food particles. Average kinetic energy of the molecules. Average kinetic energy of the average kinetic energy of the molecules of the food particles in the hot water is greater than to the average kinetic energy of the uh, uh, yes is greater than to what I'm telling here means 1.2. This is one bowl. That is the second bowl. This bowl is filled with hot water. That bowl is filled with the cool water. This bowl is filled with the hot water. That bowl is filled with cool water. This is a food game. Food colors. Food colors keeps on top surface of the water. That food colors also keeps on top surface of the cool water. Now we have to observe food particles. Now we have to observe the motion of the food colors on the earth surface. We have to observe motion of the food colors on the cool surface. Now food colors moving random directionally. That place also food colors are moving random directionally. Random directionally. Food colors on the hot surface, hot water, and hot water and the molecules of the water are moving random directionally. Random directionally. Any particles in the motion, that particle having the kinetic energy. Kinetic energy. Kinetic energy. Now, in the situation, um, in the situation, we observe that motion of the food colors in the hot water is greater than to the motion of the food colors in the cool water. Cold water. What we are going to observe. So the observer motion of food colors in hot water is greater than to motion of the food colors in a cool water. Here, this is a motion of the food colors is moving random directionally. This is a molecules of the water are moving random directionally, and this is a moving random directionally. And the molecules of the water also. This is the molecules of the hot water. This is the molecules of the cool water. These particles are very simple way. One point I'm going to finish this. This is about this wall is filled with hot water. This is about filled with cool water. This is a food grains, food colors. Food colors keeps on kept on top surface of the hot surface. This is a food color kept on top surface of the cool water. We are going to observe motion of the particles. This particle motion of the particles are random direction. This motion of the particles also random direction. These particles are random direction. This is kept on the water, hot water molecules also random direction. This is random direction. This is kept on the cool water. These molecules of the cool water are also random directions. But here, what we are going to observe compared to the both of the motion means this is a random direction. This particle attached to the molecule is also random direction. There are random direction means they are moving. They are moving means they have the kinetic energy. This is also random directions. Molecules of the water also random direction. They have the kinetic energy. So they have kinetic energy. But what is the difference means here? This is a motion of the food grains in a hot water is greater than to the motion of the motion of the food grains in a cool water. Cool water. This particle having more kinetic energy. This particle has a less kinetic energy. Less kinetic energy. So here we observe that what we are observed that we observe that motion of the food colors in a hot water is greater than to the motion of the food colors in the cool water. That is a conclusion. That is I'm observing. That is I'm observing. So final conclusion is we conclude that average kinetic energy of the molecules or particles of the hot water is greater than the cool water. Cool water. So final conclusion is what is the conclusion? Average we concluded that average kinetic energy of a molecules or particles of the hot water is greater than to the average kinetic energy of the molecules of the particles of the cool water. Cool water. That is the conclusion. That is a conclusion. Now, average kinetic energy of the molecules is directly proportional to the absolute temperature. Absolute temperature. From this conclusion is average kinetic energy of molecules or particles is directly proportional to the absolute temperature. That is the conclusion point from this conclusion. Here you see simplify. This is a one bowl. This is a second bowl. This bowl filled with hot water. This bowl is filled with cool water. Now I'm taking the food colors. Food colors are kept on the surface of the water. Food colors are kept on the cool surface of the water. Now we have to observe the motion of the food colors. Motion of the food colors are random direction that are kept in our top surface of the water. That water has a random direction. This also random direction and kept on the full surface. That also random direction. This both are in random directions means they are their motion. They have the kinetic energy. They have kinetic energy. This also random direction. This water also random direction. This body having the also kinetic energy. Kinetic energy. Here, motion of the particle is motion of the particle of the food grains of the hot water is greater than to the motion of the food curds on the cool water. Cool water. And average kinetic energy of the average kinetic energy of the particles of the molecules of the hot water is greater than to the average kinetic energy of the cool water. Cool water. Now here conclusion is what is the conclusion? Average kinetic energy of the molecules or particles is proportional to the absolute temperature. Absolute temperature. Now next activity for activity for activity 4. In this activity I'm taking, this is a jar, this is a glass tumbler, this is glass tumbler, so this is a water, this is a this glass tumbler is filled with water up to this level. This is heating up to 60 degrees centigrade. This is a hot water. Hot water. Hot water. This is a jar. Jar is filled with water. Jar is filled up of the water. This water is heated up to 60 degrees centigrade. 60 degrees centigrade. Next, I'm taking the coconut oil. This is a coconut oil. This is a hot water. This is a coconut oil. This is a coconut. Coconut. Coconut oil. Coconut oil. Coconut oil. So this is a coconut oil. This is a hot water. Both are don't mix each other. We have to take care. What we have to take care? So coconut oil and hot water both are not mixing to each other. Both coconut oil, hot water, both are not mixing to each other. Mixing to each other. We have to take care. So what we have to take care? Coconut oil, hot water, both are not mixing to each other. Mixing to each other. That is a very important point. Very important point. Now, what we have to do here? This is I'm taking the lead. I'm taking one lead. This is we call lid. We call this is a lid. This lid having two holes. This is a one hole. This is another hole. Another hole. I'm taking the thermometer. I'm taking thermometer. Thermometer. I'm taking thermometer. So what is the use of the thermometer? Thermometer is used to find out temperature. Temperature. I'm taking the two thermometers. This is a thermometer one. This is a bulb for having. This is a bulb of the thermometer having mercury. This is a mercury. This is a second thermometer. Second thermometer. Secondary thermometer. This is a first thermometer. This is a second thermometer. Secondary thermometer. This is a lid. This is a lid. This is a thermometer is this is a thermometer. This thermometer is inserted. This thermometer is thermometer kept. This is thermometer kept. This thermometer is inserted. This thermometer is passing through this hole. This thermometer, first thermometer. This is a thermometer. This thermometer lies in coconut oil. Lies in coconut oil. This thermometer lies in a coconut oil through the hole. Through the hole. This is the second thermometer. Second thermometer lies in hot water through this wall. Through this wall. So this is a completely diagram. This is a complete diagram. Now we'll see. This is a diagram is completed. What we are going to see here. So what I have to take care here. I have to take care. This is a one jar. This jar is filled with. This jar is filled up of the water. Remaining part is filled with the coconut oil. This water is heated up to 60 degrees centigrade. This is a coconut oil. Coconut oil and hot water both are not mixing to each other. This is a hot water. This is a coconut oil. Both are not mixing to each other. Both are not mixing to each other. Each other by taking the care. By taking the care. Now we'll see in this situation what will happen. This is a hot body. Hot water at high temperature. Hot water at a high temperature. High temperature. Okay. So coconut oil is taken as at low temperature. Low temperature. Initially, this is initially. Now, what will happen in this situation? Now we'll see. Heat flows from heat flows from. This is a hot water. Hot water is at high temperature. Coconut oil. Coconut oil. This is a coconut oil at a low temperature. Low temperature. Heat flows from. Heat flows from. Heat. Heat flows from body at high temperature. Body at a low temperature. Heat flows from body is at high temperature. Body at a low temperature. Heat is flowing. It is flowing. But here, hot water is taken as high temperature. Coconut oil is taken as low temperature. But heat flows from. It flows from. Now, we'll see. Heat flows from. Heat is flowing from body at high temperature to body to low temperature. Heat is flowing from. Heat is flowing from hot water to coconut oil. Coconut oil. After 10 minutes or 20 minutes, you will see. So, what is reading of thermometer? Reading of thermometer. Reading of thermometer kept in coconut oil increases. So, reading of thermometer kept in hot water is degrees. That is a conclusion. This is a activity 4. Activity 4. This is the activity. Here, so what is the conclusion here? You see the difference. Some heat some heat flows from heat is flows from hot body to cool body. Hot body to cool body. Here, so why heat flows from body at high temperature to body at low temperature means there is a temperature difference. Heat flows from body at high temperature to body at low temperature. So why does heat flows from one body to another body means what is the reason means there is temperature difference. There is temperature difference. Hot water having high temperature, cool water having low temperature. There is temperature difference. This body having high temperature, this body having low temperature. There is temperature difference. There is temperature difference. That's why heat flows from body at high temperature, body at low temperature. That is the main reason. This is activity 4. Activity 4. Now heat flows from hot water to the coconut oil. Coconut oil. Now after 10 minutes or 15 minutes, we have seen to the reading of thermometer kept in a coconut oil increases. Reading of thermometer kept in a hot water decreases. We are going to see this one. So why means there is temperature difference between the two bodies. There is temperature difference between the two bodies. Okay, this is activity 1. Okay. Now in this conclusion, what is the conclusion? Heat is a Heat is a form of energy in the transient. Heat energy flows from body at high temperature, body at low temperature, body at low temperature. Now, so temperature is a quantity which denotes which body. Temperature is a temperature is a quantity which denotes which body is cool, which body is hot. Temperature is determines direction of flow of heat. Also. Temperature indicates temperature determines the direction of heat flow. Direction of heat flow. Okay, this is activity 4. Activity 4. Now, today class is over. Tomorrow I will explain activity 5, activity 6. Now, next coming class I will explain this. Thank you. Thank you very much.